All right, let's go and take a look at chapter 2.6. Okay, 2.6 is all about solving absolute value inequalities. I'm going to make this a little bit higher so I have a little bit more space. Okay, so to solve ax plus b is less than c, for any c that's greater than 0, so this number has to be greater than 0, we'll solve two equations. So we'll solve ax plus b is less than c, and we will also solve ax plus b. Flip the sign and flip the number. Okay, so greater than negative c. So one of the equations is going to look the exact same as what we have from the original equation. And then the other equation that we have to solve, we have to flip the sign and flip the number. So change the sign of the number. And we'll take a look at a question like that. The other possibility is that we have ax plus b, absolute value of ax plus b is greater than c. Written like that. For c being greater than 0. Okay. We'll take a look at when c is 0 and when c is negative a little bit later. But for right now, let's deal with when c is greater than 0. Okay, in this we're going to solve the equation exactly like it is. So ax plus b is greater than c. And x plus b, we will also solve x plus b is flip the sign, so make it this way, and also flip the number, so make it like that. Okay, so when we solve this and the equation looks like this, or the inequality looks like this, we have to use the word and at the end of our answer. If the inequality looks like this, we will use the word or at the end of our answer. Okay, it doesn't mean that we're only going to solve one or the other. We got to solve both every time. Okay, but at the end of our answer, we'll use the word and or the word or. Okay, so let's go and take a look at a question like that. Okay, so let's say that the question says absolute value of x plus 7 is less than or equal to 2. Okay, we notice that this sign looks like that sign, right? We can replace this with the less than or equal to. Okay, so our sign is facing the same way as that one. So first we're going to solve ax plus b is less than c, so exactly what we have of x plus 7 is less than or equal to 2, right? So take what you have here, and then take the sign, and take the number. Okay. The other equation that you'll solve is ax plus b, so this inside of your absolute value stuff, so x plus 7, flip the sign. Okay, so flip the sign, and flip the number, so make it negative 2. Okay, so we'll solve these two equations. So minus 7, x is going to be less than or equal to negative 5. And then x minus 7, x is going to be greater than or equal to negative 9. Okay, remember, we used this sign in the question, so we're going to take this one, and we see that we have to use the word and at the end of our answer. Okay, so being less than negative 5, close circle, and greater than negative 9, close circle. Okay, so the answer would look like this, and if we wanted to combine all of this into one, we could say that negative 9 is less than or equal to x is less than or equal to negative 5, and that looks good. All right, let's go take a look at another question. All right, let's say that the question is 8x minus 11 is less than 0. Okay, the one thing that we know about absolute value is that absolute value at the end of the day, whatever we get in here will have to be a positive number. Okay, and they're saying positive being less than 0. We know that positive numbers are not less than 0, so like positive 5 is greater than 0, so this could not be true, right? Positive numbers will never be less than a 0 number. Okay, so no solution, right? This would be equally true if it said less than negative 5, right? So we know that positive numbers will never be less than a negative number, so there's no solution. Okay, If it was like this, on the other hand, where the sign was facing towards the absolute value stuff, we know that positive would always be greater than a negative number. Like this could have been -5, it could have been -30. We know that this was going to be positive at the end of the day, and this is a negative number. So we know that positives are greater than negatives. So this is going to be all solutions. All solutions. Right. So let's go and take a look at a similar question. Right, let's say that we have c minus 1. Absolute value of c minus 1 is greater than or equal to 5. Okay, notice that our sign is facing this way, right? The same as this one. Okay, so we're going to solve these two equations. We're going to solve ax plus b is greater than c, so exactly the way it looks. So c minus 1 is greater than or equal to 5. We're going to solve that. We're also going to solve the ax plus b, which is the inside of your absolute value stuff. So c is c minus 1. Flip the sign, right? And flip the number. So it should become -5. Okay, so adding 1 to both sides gives us c is greater than or equal to 5 plus 1, which is 6. And then c minus 1, add 1 to each side, we get c is less than or equal to -5 plus 1, which is -4. Okay, and notice that our original sign was facing this way, right, towards the inequality sign, and which is the same as this one, so we should use the word or at the end of our answer. And to graph this, c is less than or equal to -4. So less than or equal to is facing this way. Okay, c is greater than or equal to 6. So 6 is over here. Close circle facing that way. And so or inequalities do face away from each other. All right. Let's take a look at this next question that says absolute value of 10 minus 3m is greater than or equal to -2. Okay, so what do we know about absolute value? That at the end of the day, whatever this is going to be a positive number, right? Our answer to whatever we have will be a positive number. Is positive going to be greater than or equal to, this is a negative number, so looking at it like this, are positives greater than negative numbers? This is yes, this is true. So all solutions. Okay, let's take a look at the last question. So let's say that we had something a little bit longer, like 4. I'm going to write it to the left a little bit so I have all the space to deal with. So 4, absolute value of x, 2x minus 6 plus 1 is greater than 21. Okay, there's quite a few things here happening here. Okay, so what I'm going to say is I'm going to treat this as x, and I'm going to get this stuff by itself. So how do we do that? We've been doing that. All right, so 4x plus 1 is greater than 21. If we subtract 1 to both sides, this becomes 4x is greater than 20. And if we divide 4 by both sides, we get x is greater than 5. Okay, so we said that this was x. So we're going to say that 2x minus 6, which is what we're saying that x is greater than 5. Okay, so based on this, we see that we're going to use this rule, write these equations, these inequalities. So ax plus b is greater than c, which is exactly what we have right now. So 2x minus 6 is greater than 5. Right? The other inequality that we'll solve is inside of our absolute value. So 2x minus 6, and then flip the sign, right? So flip the sign, and then flip the number also. Okay, so less than -5. Okay, so if we add 6 to both sides, we would get 2x is greater than 11, and dividing both sides by 2, we get x is greater than 11 over 2. Okay, so that's part of our answer. I'm gonna get rid of this so I can just say that we did it right here, right? We put in the x right there. And then add 6 to both sides, add 6, we get 2x is less than 1, and then divide by 2, so x is less than 1 over 2. And notice that we use this, so we gotta use the word or. So x is greater than 11 over 2, or x is less than 1/2. And I'm gonna erase this now because we've had it up there for a little while. And let's draw the inequality on a number line. Okay, so 11 over 2 and 1/2. So 11 over 2 is the same as like 5.5. Okay, so instead of writing 11 over 2, I'll just write it as 5.5. It's going to be greater than 5.5, okay, which is 11 over 2. And then 1/2 is about 0.5, right? So 1/2 is 0.5, and that's going to be less than 0.5. So there's our answer.